Welcome back to the live coding session of a flagship game. Today we have to add functionalities to our game because we started developing the game in the last days, but we just drew the interface without actually adding any functionalities to it. In particular, what we have to do right now is to deal with tapping on the flags, because what we have so far is just an interface which displays 16 flags taken from a set of 38 countries. They are displayed in a random order on a grid which is a 4x4 grid. Now we have to make it possible for the player to tap on the flags and to see if the taps are properly follow the proper order, which is the alphabetical order according to the challenge that the game is proposing. So let me open up the emulator and show you which is the starting point for today, which is this one. Actually, I have to reduce the size of the mockup and to put here the last version that we developed together to show you that right now, each time that we restart the game, a different set of flags and a different ordering of flags is proposed, but no actions are associated with the taps that I make on the flags. On the other hand, all the flags are contained in this square region, which corresponds to a canvas. Canvas are interface elements which are sensitive to events, input events happening on them. In particular, the canvas that we are using is called the grid, and if I press grid into the block editor, I find canvas specific blocks. And the one which I'm going to use is this one, which is called the when grid touched, which is sensitive to touches on the area of the screen covered by the canvas. There are local variables associated with it, which are x, y, and touched sprite. X and y are the coordinates of the touched point in the screen. They are relative coordinates starting from this corner here at the top left. And then I have also the object which has been touched, and given that we have 16 sprites in our canvas, it is very useful to know which one has been possibly touched. Notice also that it is possible to touch the canvas without touching any flag, and in this case we don't need to do anything because we don't need these borders to be sensitive to end-user touches. And actually we left them just to avoid misunderstanding the touches if the flags were too close to each other. So now what I have to do first of all is to avoid doing something in case of a forced tap. So I go into the control and I take this if statement here, and I say that I want to do something if and only if there is a touched sprite. So get touched sprite returns 0 or null in case of no sprite touched. So if there is a touched sprite, I want to be sensitive to this touch. Then, in case a sprite was touched, I need to understand which is the sprite which has been touched. And to this purpose, I define a local variable which will be called current, which represents the current sprite touched by the user. I initialize this variable to 0, taking a constant from the math panel, and then I set this variable, this local variable, which is this one, to a value which represents the position of the touched sprite. To this purpose, I can define a new procedure returning the value, and the procedure will be called which flag, because I want this procedure to return the position of the tapped flag. And I want also this function to understand which was the tapped flag based on the input parameters that are passed to it. And the two parameters that I want to use are x and y, which are the coordinates of the touched point in the screen. And in order to understand which is the flag from the coordinates, in practice, I need to do something which is the more or less what I did to place the flags into the grid. So as you remember, I defined a cell width, which was 1/4 of the width of the entire screen. And based on that, I said that the first one of the flags or of the cells was positioned in at coordinates 0, 0 as rows and columns, so corresponding to 0 as a y-axis and 0 in the x-axis. So this was the corner of the cell. Then moving in the row, I added one size cell width to go from a cell to the next one horizontally, and I did the same vertically. So right now, having this in mind, I can invert this procedure and try to find out which is the cell in which the touch happened based on the coordinates. So to this purpose, let me show you how we can do it. We have to do some math, and we will first of all define a local variable which represents a position, so it's an integer number, and we can call it I'm sorry, I need to use a different block, which is the one which has a return value, and I will call it n, which is the position, and I initialize it to 0. Math 0. Okay, then I take a do statement, which is what I need to do in case of a return value to be able to put instructions inside this function, while the return value will be the local variable n, which will be then assigned to what is called the current in the external procedure, which is this one. Now, inside this, I have to do something which requires me, first of all, to compute the width of a cell, as I did when preparing the screen and placing the flags. So to this purpose, I define another variable which is local and called cell width, and cell width will be assigned with the round of the result of the game width, which is a global variable, this one, divided by 4, which is the number of columns, and also the number of rows, of course. Now, having the number of pixels taken by each cell horizontally and vertically, I can divide x and y by this quantity in order to find out in which rows and which column we are. And the actual position of the flag will be represented by an integer which corresponds to the actual row multiplied by 4 plus the current column. So I need to assign to variable n the result of some math, which is a plus, because I want to compute the column and add it to the computation of the actual row in which I am, multiplied by 4, which is the number of positions in each row. So, for instance, if I am here, this is the first row, first column. I want this position to be called 1. To this purpose, I recognize that I am in the first column and that I don't need to multiply it and to add any row, because in the first row there is no offset with respect to 0. If I am in the second row, for instance, second position, this is the 6th flag, because flags are numbered this way: 1, 2, 3, 4, 5, 6. And 6 is 2, which is the column, plus 1, which is number of rows minus 1, times 4, which is the number of flags in each row. So let me do this computation directly in the code, and then I hope it will become clearer. So here I put the number of the column in which I am, and to this purpose I need to divide the x coordinate by 4. Then I take this, I duplicate it, sorry, not by 4, but by cell W. Sorry about that, because I have to divide the actual coordinate by the width of each cell. Then I take this, I duplicate it, I copy and paste it here, and I change x in y, because in this way I will determine the number of rows in which I am. But this is something that can return a result which is not an integer, because assume that I tap here. The result of this division will be something which is 1.5 more or less, because 1 would be here, which is exactly the width of a cell or the height of a cell. This would be 2, and this is something in between, which is a fractional number. I want in this case to take the what is called mathematics the floor, which is the integer which is right lower than the actual number that I get. So if the number is 1.4, for instance, the floor is 1. So in math, I find the floor operator here, and if I add it here, I obtain what I wanted. So this will be 0 if this fraction is less than 1, and it will be 1 if this function is between 0 and between 1 and 2, sorry. I need the floor to be added also to the other coordinate, which is this one. Okay. And now I need to multiply by 4 the column number, because if I am in the row number, because if I am in the second row, which corresponds to number 1 in this case, I need to multiply it by 4 to take into account the 4 flags which were in the previous row. So I go again into the Math tab, and I take a multiplier, I put it here, I put the multiplier here, I'm sorry, the floor has to be here, and then I multiply by 4. Then the last thing that I need to do is to add 1 to the column position, because the first column position is 0 according to the floor operator, or otherwise I can change the floor operator into ceiling, which is the integer which is right above the number that is the result of this division. Okay, so right now I should be able to know which is the position of the tapped flag, and in order to make sure that it works, I do this way. So first of all, I need this function to be called somewhere, and the place where I need to call it is this one. So I call function which flag, which is this one from here. And then I need to pass the 2 parameters to this function, which are x and y. So x and y. So x is here, y can be taken from here, and now it should work. To double check if it works, I can use a label which is not yet used, like this one, which is exactly, let me see, this one called next val, and I can change the text of this label. I took the wrong instruction, so the proper one is set next val text, and if I place it here, sorry, here, and I assign current to it, in this position, every time I tap a flag, I should find the number of the tapped cell in the grid. Let's see if it works. So let me build this and save it in my file system in order to be able to upload it on the emulator. Okay, just a few seconds. So if everything works fine, the current position of the cell should appear here in this position in the new version of the code. So let's go to the download folder. Okay, I'm waiting for the APK to be downloaded in my file system. Apparently the App Inventor server is overloaded because it is taking much longer than usual. Almost done, I hope. Okay, here it is. Let's see if it works. Play the game. Okay. You see, a 4 appears here because I tapped on the fourth flag. 1, 2, 3, 4. If I tap here, this is 2, this is 1. If I tap here, this is 2. Oops, it doesn't work. So let's go and try to double check why it doesn't work. So you see that we are using this label for debugging. So we are testing the functionality that we just implemented to see if it works, and we do some other experiment to see what's wrong. So as you can see, the horizontal position is properly understood, while the vertical one is misunderstood or not properly combined with the horizontal one. So let's go and try to find the programming error together. Okay, so I hope that you see the error which is apparent, because instead of multiplying by 4, I multiplied by 0. So it is quite simple to fix. And now let's see if it takes a little shorter than before to recompile and download the new version of the APK to see if it works. I get rid of these sparse elements, which are just like debris. Okay, much faster, hopefully. New version, play the game. 1, 4, 7. So now it works properly. Oops. Okay, let's try it again. This is just a problem of the emulator. It's not just a problem of functionality. Okay, 16, 12, 11, 8, 4. Okay, it works. So that's a very good starting point now, because we added sensitivity to the tabs, and now we know which position was tapped. So this means that we can start implementing the game by trying to figure out if the tabs are in the proper order or not. So to this purpose, we need to associate with each tab a value, which is the value of the parameter associated with the flag in that particular position. And at each tab, we need to double check if the value associated with the tapped flag is greater or equal than the one associated with the last tapped one. Okay, so this is what we try to do right now. Let's see. We go back to this code segment here because we are still implementing the functionality associated with a tap in the grid, which is our canvas, and in particular we are inserting further instructions within this if statement, which is executed only if a sprite is touched. Then now we have the actual position of the touched sprite, and we can try to verify which is the flag which was placed in that particular position. So flags are sprites. So we have a list of sprites which is called the cells, which is a global variable, and we also need a counter of the taps that we do. So what we can do is to try to initialize a local variable which contains the value of the sorting parameter associated with the tapped flag. I go to the variable menu and I add a local variable here. This local variable represents the current value of the sorting parameter, so I call it the car val. And I can directly initialize it at the proper value, which is taken from a list. The position in the list is represented by variable current, is this one, while the list is a list that I added before starting this session, which contains all the values associated with the flags. Notice that since we are trying to sort flags in alphabetical order, instead of making a comparison between two strings in order to see if they are in alphabetical order, I decided to use numbers because all other sorting criteria will be numerical in nature. So instead of doing something special just for the alphabetical order, I decided to use numbers representing the position in the alphabetical order of the countries that we have in our set. So this list of numbers represent the value that can be interpreted as the positions of the countries associated with the flags in the alphabetical order. Okay, so having this list, I can just take the value which corresponds to the position that I tapped, and I will do it directly here. But notice that if here I use directly this list, which is a global variable called cells, called values, I do something which is not coherent. Because if you remember, when placing the flags into the grid, we used the original set of 38 flags, but then we took just 16 of them and we placed them in a shorter list, not only taking 16 out of 38, but also changing their order. So I need to do the same with a list of values in order to do something which is coherent. So let's go back to what we did yesterday and see how we need to implement it for doing the same with values. So the functions that we implemented yesterday are these ones. Get data, which call randomized and selected countries. Selected countries is the restricted list of 16 countries in random order. Now we need to do exactly the same for the list of values. And we need to extract a subset also from the list of values using the same randomized set of positions in order to take exactly the values associated with the countries from which we are taking the flags. And we have to use for sure a different variable to represent the restricted list of values, and it will be called selected values. Selected values, and we can initialize it to an empty list because it will be then reassigned here, and there is the selected values variable. Now I can use this selected variable in place of this one, which are just the values, and at this point the value will be correct, and to see if it's correct, I take this statement and I use the same label that I used before to represent this time the current value. So let's see what happens. What I expect to happen is that instead of displaying the position of the flag in the grid, this will show the actual position of the flag in the original list. So the number appearing in the label should represent the position of the country represented by the flag into the alphabetical order. Let's wait for the new APK. In the meantime, I close the previous version. Still building the package. Almost done. It seems that the last 5% is the hardest one. But it's just a matter of traffic, because it takes much shorter to just build the package when there are not so many users connected at the same time. Okay, here we are. Download folder, this one, it's version 5. And let's see what happens. Play the game. So let me start from Switzerland. You see, now the number is 35. 35 is something that cannot represent the position in the grid, because the grid contains just 16 flags. So 35 is the position of Switzerland in the overall alphabetical order of the 38 countries. So the last one of the 38 countries, I think it's United Kingdom. United Kingdom is not represented here, but we can restart the game to see if it appears. Here it is. And you see, it is 38, which is the last one in the list. This is number 3, which is Belgium, because it starts by B. And the first one should be Austrian. Let me see if we manage to have Austria here. Okay, doesn't matter. Okay, here it is. So number 1. Okay, so it works. Now we are in very good shape, because we know exactly the value associated with the tapped flag. So we can decide if this tap is correct or not by comparing the value associated with this tap with the value associated with the last one. So let's go back to App Inventor, and what we can do here is to use an if statement. Sorry, inside here. Let me keep it here and say that if, and we do a comparison here. This is greater or equal than. And we say that if current value greater or equal than, and we need a global variable here called previous value, initialized to 0, and here we take this variable, then this is a correct tap. Otherwise it is not. So otherwise is the else statement, and in order to manage to decide what to do when the tap is correct and when it is not, we can do this, which is just adding 2 specific procedures, one called correct tap and the other one called wrong tap. And here we can just call them correct tap and wrong tap. Then I need to do something else, which is update the current value. In case of correct tap, what I expect is the current value to be greater or equal than the previous one. So in order to verify next tap, I need to store the value of the current val into prev val, which will be used at the next tap. So I take this and I set previous val to current val. Okay, now I need to decide what to do, but first of all I want to decide what to do in case of a wrong tab. And to make it apparent that the tab was wrong, according to our specification, what I want to do is to make the flag disappear in case of a wrong tab. So what I want to implement here is this kind of effect. And to this purpose, I need to know which was the touched sprite. So I need to pass something to this function, which is wrong tab, and in particular I will pass an input parameter which is exactly the touched sprite. I call it sprite. And then I make the sprite disappear. To this purpose, I need to use one of these elements which are called any component, and in particular go into the image sprites and make use of this statement which is set image sprite visible, if I remember properly. Here it is. Okay. So set image sprite visible of component sprite 2, and I take a logic constant which is false. And in this way, I make the flag disappear. Now I have one more issue, which is dealing with the first tab, because second tab will be compared with the previous one. But what about the first one? I need the first tab to be always correct. And to this purpose, I need to know which is the first tab. So let me add a counter, which is a global variable. Counter, I initialize it to 0. And at each tap, which is not a forced tap, so this means a tap which hits a sprite, I increment this counter. But then I have also to say that if this counter is 0, then the tap is always correct. So this is something that has to be added to this condition here. So let me do it this way. Instead of just expressing a condition which is based on that, I can use a logic operator which is OR, which says that the tap is correct if this condition holds, or if the counter is equal to 0, meaning that this is the first tap. And then inside here, I will also increment the counter. So this will be done this way. I will say global counter equal global counter plus 1. Okay, it's time to see if it works. Notice that correct tap is not yet implemented because we are not still dealing with score. We want just to make the flags disappear if they are tapped in the wrong order. Okay, we are almost done. No, we are not. Still 35%. Okay, while waiting, I try to figure out together with you what we need to do next, because then we need to add the score. So this means that in case of a correct tap, the score will be computed and incremented according to the specifications. If you remember, our specification says that we need to multiply the score earned so far by the user by the number of correct tap so far. So this means that the first correct tap is worth 1, the second correct tap is worth 2, and the total score will be 1 by 2, and the third one it will become 1 by 2 by 3, so 6, and the fourth total score will be the factorial number of the correct taps. And of course, wrong taps won't contribute to the score. Okay, let's see if it works. Play the game. Okay, let me see. This is correct because this is the first one. Then I tap this one and it is not correct. So it should have disappeared while it didn't. So it is not working properly because as you can see, we find here the values which represent the position in the overall ordering. And if I tap on United Kingdom, which has the highest possible value, all the other ones should be wrong. So they should disappear as soon as I tap on them. So there is something wrong. Let's see what's wrong here. Okay, now here we have that the global counter, okay, again the same error that I made before. I took a constant which is 0 and I forgot to change it in 1. So I never increment the counter so that this code consider all the taps as the first one, because this condition is always true if I never increment the counter. So I'm sorry about the delay, I have to rebuild it, but on the other hand, for educational purposes, debugging is even more important than coding, because when coding, it is very likely to make errors, and errors requires testing, and if something is not compliant with the specifications, we need to understand where is the error that we made. So if we are lucky, this was the only error in this piece of code, and now it should work. But you never know until you test it. So we need to wait for this new version to be built and downloaded in order to make sure that now it works. If it works, we can consider this section to be concluded, because this was about the sensitivity of the canvas to the tabs and the basic functionalities, while next one will be about score. Okay, here it is. New version. Play the game. Okay. This is 3. This is 13, which is good. This is 30, which is good. And this is, oops, problem with the application. Property setter was expecting an image sprite component, but got a Boolean instead. This is a syntax error, not just a logical error. So let's go back and see what's wrong. Okay. Set image sprite. Visible, this is a sprite. Get touched sprite. Oh, this is I see what I did wrong. So touched sprite is not a reference to the actual touched sprite, but it's just a Boolean that means a logic value that takes value true if there is a touched sprite and false if there isn't. So what I need to do here is to take the current sprite from a list using the variable called current as an index and the global variable called cells as a list, which is the list of sprites. Okay, let me try it again. So this is my fault, because I misunderstood the interface of this function, because this touched sprite was not what I meant it to be. So I thought that it was directly a reference, while you see, if you read the specification of this function, actually is written in very small character, but it says that touched sprite is true if the same touch also touched the sprite, and false otherwise. So if I had read this specification, I would avoid this error. Okay, new version ready. Let's go and test it. Here we are. Okay, let's start from here, which is 27, and then here. Great, 13 has disappeared. 18 has disappeared because we tapped on 23. Then we have this one, which is 19. This one is 14. 32 didn't disappear because it's correct. this is wrong, this is correct, this is wrong, this is wrong, and this is the only one which is still correct. So now this is correct and all the other ones are wrong. Great, so it works. Okay, oops, what's wrong now? All of them have become wrong. Okay, this is an issue that we need to deal with. What I need to do is to make the tapped flags insensitive to other taps. So this is something that needs to be done, or otherwise we will keep having flags disappear, even if we touch them twice, just because we are not tapping them just once, which is what the specification tells us to do. So this is something that needs to be managed, and to this purpose I can just make them, I can do it in two different ways. I can associate a flag with I'm sorry, in informatics flag is not just what we are dealing with, which are the flags associated with countries, but the flag is also a Boolean variable which can take a value 1 or 0 or true or false, depending on the fact that its status is a given one or another one in case there are only two. So what I need to do is associate this kind of variable with each sprite, which is flag, in order to remember if it has been already pressed. Or otherwise, I can just disable a sprite. So this means that I can make it insensitive to touches. And in both cases, I can achieve the result that I want, which is that the flags which have been already tapped and classified as correct or wrong cannot be reevaluated if we tap them again. Okay? So that's it for this session. Thank you for your attention, and sorry again for starting it late. Thanks.